Module 4, Lesson 11, takes us into the next kind of phase of looking at properties, and we're going to look at factoring expressions. And so here are a couple examples that come from your lesson, but I'd like you to have in your notes just as a reference point. So when we draw models, what we do if we're adding 5 plus 5 plus 3 plus 3, we would have the boxes representing 5, 5, 3, and 3, and then you would just add it all together. 5 plus 5 is 10, 3 plus 3 is 6, and then that would give you 16. Now, when we're looking at factoring, though, we actually can take repeated addition and create multiplication problems out of them. So we have a 5 plus 5, which is the same as 2 times 5, and we have a 3 plus 3, which is the same as 2 times 3. So what we have is, what it's showing you, is that 5 plus 5 plus 3 plus 3 is equal to 2 times 5 plus 2 times 3. Now, with the factoring, what you can do is, in this multiplication problem and this multiplication problem, you have a 2 in both of them. And so what you can do is actually factor out the 2, leaving the 5, the plus sign, and the 3. And that goes on the inside, so that's 5 plus 3 times 2. And the way you would solve that is that you would take 2 times 5, which gives you this, keep the addition sign, and then you take 2 times 3, which gives you 2 times 3. All right, looking here, we have another one, and because of our commutative property, we're able to change the order and still get the same answer. So we have a 5 plus 3 and a 5 plus 3. So what we have is two groups of 5 plus 3, which would be 2 times 5 plus 3. And again, following the distributive property, we take 2 times 5 first, and we write 2 times 5. We keep that addition sign, that goes in between them, and then we take 2 times 3, and that's how we get our 2 times 3 over here. You want to put your parentheses around them, because if you do not, it can kind of get a little confusing because you have that addition sign in between them. And though with the order of operations you'd have to multiply first, a lot of people would look at that and feel confused. So 2 times 5 plus 3 is equal to 2 times 5 plus 2 times 3. This is a demonstration of the distributive property. So again, you take 2 times 5, that is your first one, plus, that goes in between it, and then you have a 2 times 3, and that is over there. So distributive property, we're just going to keep working with that. So we have here A plus B plus B, so that's 2A, and then 2B. In the same way that when we had our, up here at the top, see how we had 5 plus 5 was 2 times 5? That's why A plus A is 2 times A. And then just like 3 times 3 was 2 times 3, we have B plus B is 2B. So what we have are two groups of A plus, we have two groups of A plus two groups of B. So this is our variable A and our variable B. So two groups of A plus two groups of B, two groups of A plus two groups of B. They both have that 2 in the front, so we can factor that out, put that 2 there, keep our A, keep our plus, keep our B, and that goes in our parentheses. And again, that's the distributive property. So if we look here, we have A plus B plus A plus B. And that would be two groups of A plus B. Two groups of A plus B is written this way. And then using the distributive property, I take 2 times A first, and that becomes my first one. Then I take 2 times B, which gives me 2B, and then we have that plus sign in between it, and that's the distributive property with only variables and a 2. So if you look here, we have just a couple more examples for you. You have 3F plus 3G. They both have 3. We take that out. It becomes the first number. We keep F. That goes inside the parentheses. We keep our plus sign. That goes in there. And then we keep our G, and that goes there. But we have to put those in the parentheses because we have 3 groups of F and 3 groups of G. Over here, we have 6x plus 9y. Now, when you're given something like this, you think, oh, well, the letters aren't the same, or the numbers aren't the same, and the letters aren't the same. So what do I factor out? Well, if you look at 6 is 3 times 2. So we can expand 6x to 3 times 2 times x, and expand 9 to 3 times y. because 3 times 3 is 9. And so they both have a 3, so I can take this 3, pull it out, it goes here, and then I have what's left, which is 2 times x, so we'd write 2x. We have our plus sign, so that goes here, and we still have 3y, which then goes there. And so you have a three groups of 2x plus 3y. Now, you also could have a situation where they give you letters, and the letters are what they have in common. So let's say we have a 2f plus 5g. Well, my numbers aren't the same. I can't factor anything out of 2 and 5, but I'm sorry, this should be an f. So my 2 and 5 can't be factored, but I have an f in both. And so what you can do, because the f is what's shared, because that's the same number, you actually would have your f on the outside, and then you take your 2, because that's what's left. We take our plus sign, and we take our 5. So we have 2 plus 5, and now we can actually solve it. So 2 plus 5 in our parentheses is 7. And so this would be f times 7, which you always want your number to come first, and so the way you would write that is actually 7f. And so that's how you could simplify it. But right here is the distributive property, because I'd take f times 2, so right here, f times 5, which is right here. So the distributive property, that's what we'll be using this entire lesson. Right now, I'd like you to go ahead and open your book and turn to lesson 11, and it will look like this. And we're just going to talk through these models again. So how many 5s are in the model? We have 2 5s. How many 3s? 2 of them. How does the expression represent, or what does the expression represent in words? 2 groups of 5 plus 2 groups of 3. What expression could we write to represent the model? Well, we have 2 times 5 plus 2 times 3. And then you look at this and you think, all right, with both of these, we have a 2. So I'm going to pull out my 2. Well, the other way you could write it is that you pull out your 2. I keep my 5, that goes here. Keep my plus sign, that goes there. And I keep my 3, and that goes there. And so this is the 2 ways you can do it. This is the factoring way of doing it. This is also when you multiply it out, that is the distributive property. So down below, we're going to do this again. How many 5s are in the model? We have 2 5s. How many 3s are in the model? 2. What does the expression represent in words? We have 2 groups of 5 plus 3. What expression could we write to represent the model? 2 groups of 5 plus 3. So the question is the model in part A equivalent to the model in part B? So what they're saying is 2 times 5 plus 2 times 3 equal to 2 times 5 plus 3? And the answer is yes, because of the distributive property. What relationship do we see happening on either side of the equal sign? They have 2 groups. So down here, well, I gave you the property right here. So this is the distributive property. And again, the way that works is you take 2 times 5 plus 3, and you take your 2 times 5. So this here goes there. We have our plus sign. And then we have to take our 2 times 3. All right, down here we have another one. What does the model represent in words? We have 2 groups of A plus 2 groups of B. And that's what that means. 2 groups of A, 2 groups of B. What does 2A mean? A plus A. How many A's are in the model? 2. How many B's are in the model? 2. We're just counting. And then what expression could we write to represent this model up here? So we have two groups of A plus B. How many A's are in the expression? 2. How many B's? 2. What expression could we write to represent the model? 2 times A plus B. Are the two expressions equivalent? Yes. The distributive property, I guess this should be a capital, states 2A plus B equals 2 times A plus 2 times B. All right, down here we have using greatest common factor and the distributive property to write equivalent expressions. So this is when we need to look at our numbers and say, do they share a factor? Or do they share a number they both can be divided by? When we get lucky, they're either going to have the same number or the same letter. So with this one, they share the 3. And this is multiplication and this is multiplication. For the distributive property, you have to have these multiplication pieces here. Because if they aren't multiplying with an addition sign between them, the distributive property is no longer true. So I have my 3 and my 3, so that goes out front, parenthesis. I keep my F, my addition, and then my other one. So that would be the equivalent expression. So what is the question asking us to do? Factor. How would problem 1 look if we expanded each term? Well, that would be 3 times F plus 3 times G. And what is the greatest common factor for problem 1? It's 3. How can we use the greatest common factor to write this expression? Using the, it's reversing the distributive property is what you're doing. So the way you are able to show that is the greatest common factor between 3 is 3. And so we put our greatest common factor right there. And then in parentheses, we put whatever is left in that equation. Going on to the next page, you have 6x plus 9y. Well, looking at my numbers, I'm thinking, nope, those aren't the same number. Then if I look at the letters, my letters aren't the same either. And so if my letters aren't the same, then I have to actually look at my numbers and factor out my pieces. So looking at 6, I can, you can do your factor trees where you have a 6, and then you do 6 divided by 1 is 6. 6 divided by 2 is 3, and then you're done. So those are all my factors for 6. And then we have a 9. 9 divided by 1 is 9. We can't divide 9 by 2. 9 divided by 3 is 3. So my only common factor is 3, which means I'm going to put my 3 here. Now what I have to do is factor 3 out of 9. So I take 3, 6 divided by 3, you get 3 times 2 times x plus, then I have my 9 divided by 3. So that's a 3 times 3 times y. So then what I have here are my 3's, which I wrote right here. And then I have to take what's left. So I'm looking at my groups, and that gives me a 2x plus a 3y. So that's a 3 times 2x plus 3y. And when you expand the terms, you have 3 times 2 times x plus 3 times 3 times y. And the greatest common factor is a 3. And when we rewrite the expression, you have that above. So down here, I have a 3c plus 11c. Well, my greatest common factor is that letter right there. So I can put that letter out front, and then I take my numbers, and I put them in the rest of the problem. I have an addition sign between them, and then an 11. So that's c times 3 plus 11. And if you were to, well, we'll just leave it like that for now. go on to our next one. We have 24b plus 8. And again, we have a situation where I need to find the greatest common factor. So I have a 24, so I'm going to say, all right, 24 divided by 1 is 24. 24 divided by 2 is 12. 24 divided by 3 is 8. Divided by 4 is 6, and then I'm done. Now I have 8. 8 divided by 1 is 8. Divided by 2 is 4, and then I'm done. So looking at all my numbers, I'm looking for the greatest common factor, and the largest one I have is an 8. So then what I can do is I'm going to expand this problem. I have a 24, and I'm needing to use my 8. So I'm going to show 24 is the same as 8 times 3, and then we're multiplying it by b, plus, and then 8 is just 8. And if 8 divided by 8 are found, what would be the factor of 8? We have 8 times 1. So then my problem is I take my 8 out, and that's the front. Then I have a 3b left. I have my plus sign, and then I have a 1. And so it's 8 times 3b plus 1. Now, the reason we have a 1 in the parentheses is that with the distributive property, we have to multiply out, and 8 times 1 gives me the 8 that is in the original problem. Now, on the next page, this is going to really help me see which of you are going to need additional support with the factoring. The biggest part is to remember to find the greatest common factor. Now, I am going to ask that you do all of these problems on your own. So you're going to do A through G. So all the way down, A through G. And then you do not need to do H. And then you're going to solve number 2, and you're going to do 2A, B, C. You do not need to do this part. And then you'll need to do the bottom here. So I want you to use your words to answer the question here, and then I want you to fill in the blank here. And then at the very end, you're going to explain how you determine a missing number. Now, I'm going to go ahead and give you an example of these bottom ones just so that you have, well, I'll do the first one. I'll pick your last one. So down here. So you have 55m plus 11. Now, my m isn't in the other one, so that's not the greatest common factor. So now I'm going to have to do my factor tree. So I have a 55. 1 times 55 is 55. I can't do anything until I get to 11 and 5. And then I go to 11, and my factors for 11 are just 1 and 11. So that means 11 is my factor. So I'm going to take 11 out. I'm going to put it here. 55 divided by 11 is 5. I keep my m, keep my plus sign. 11 divided by 11 is 1. And this would be your equation. Now, down here, we're actually filling in a formula, which is a part of an algebraic critical standard. And so we have 6x plus 21y and 3 times 2x plus 7y. And they want us to solve for each one. They say x is 3 and y is 4. So what I'm going to do is I'm going to replace my x with 3. So that's 6 times x plus 21 times my y is 4. If it helps, you can even write these numbers by that letter. So that's a 3, that y is a 4, this x is a 3, that y is a 4. So I'm going to solve this first. Okay, so this should be a 3. So I have 6 times 3, which is 18. And I have 21 times 4, which is 84. If I add those together, that gives me 102. Now I'm going to have to solve this one over here. So I have a 3 times 2 times 3 plus 7 times 4. So I have to solve my parentheses first. I have a 6 plus 7 times 4 and then I do a 6 plus 28, and 6 plus 28 is 34, so this is a 3 times 34, and 3 times 34, 3 times 4 is 12, carry your 1, 3 times 3 is 9, 3 times 3 is 9, plus 1 is 10, and that gives you 102, which is the same as the first one, which just proves that the distributive property and factoring do result in equations that are equivalent to each other. So I want you to solve the rest of those, finish the next page, and I will have an answer sheet for you to check your work on.